Hey friends, welcome back to another episode of ESP32 MicroPython series. In this you will be looking at the ESP32's ADC functionality. The ESP32 ADC functionality is available on pins 32 to 39 and pins 0 to 4, 12, 15, 20, and 25 to 27, that is the ADC block 2. An exception is on block 2. ADC block 2 is also used by Wi-Fi, and so attempting to read analog values from block 2 pins when Wi-Fi is active will raise an exception. ESP32's ADC pins have 12-bit resolution by default. Its range is from 0 to 4095. So why is the Arduino's value in range of 0 to 1020? Because the Arduino have a 10-bit resolution. Don't worry, if you want it in the range of 0 to 1023, you can change it for ESP32. That many complain that the ADC is not that accurate on our ESP32. To read the analog inputs, we need to import the ADC class, and we are also importing the pin and the time module here. We need to create an ADC object or a variable to store the values. To read different voltages, we need to use attenuation. For that, we use the attend method, and here we pass this as the argument. We can also pass other values like this. For 100 millivolt and between and 50 millivolt, you can pass 0 dB attenuation. For 100 millivolt to 1250, you can give this, and also for full range attenuation, you can give this as the argument. Setting higher attenuation, it is possible to read higher voltages. Now we just need to put it in a while loop to continuously get the output from it. We are just reading the variable here or the ADC object and just giving a little time delay or time dot sleep. For demonstration, I have connected a potentiometer to the GPIO 4. Now let us connect one of its pins to the ground and the other to 3.3 volts. First, let's go and run the code with 11 dB attenuation. So here we go, you can see the output there. Let me change the port value now. You can see the output is also changing.
You can see the value is close to something around 1000, 8010.
Now let's try it with 0 dB attenuation. That is from the full range is 1.2 volt. So now let's run that code. Let's try it, and you can see it's actually closer to the 12-bit resolution, that is 4095 value. By setting higher attenuation, it is possible to read higher voltages. By default, the resolution of ESP32 is 12-bit. If you want, you can change it to other resolutions. Here I'm going to change it to a 10-bit resolution, or you can use others, like you can change it to 9-bit, 10-bit, 11-bit, and 12-bit. So here you need to use the width method, and in it you can just pass the argument like this: adc.width underscore 10-bit. So now let's go and run the code. I'm going to change the value. Yes, yeah, it's closer to 1023. You can see that even with 0 dB resolution, attenuation, you are still getting it in the range of 1023. If you want, you can also read the value in microvolts. Like here, you just use the print and comp.read UV, that is microvolt. So let's see, you can see the output there, it's in microvolts. .read microvolts returns a calibrated input voltage before attenuation in microvolts. The return value has only microvolt resolution, that is, it will always be a multiple of 1000 microvolts. If you want a more linear and consistent result, you can use this thing right here, read underscore micro 16, maybe in 16-bit resolution, I'm not sure about that. There are also other things, like you can connect a pin, or you can use the block itself and do other stuffs. So These are the basic things that you need to get started with ADC, or the analog functionality of the ESP32.